The early architecture of Web3 was built for human attention, relying on user interfaces and speculative trading apps. But the actual evolution of the network is invisible. It is a self-operating web built entirely on machine-to-machine execution rails. In a high-velocity digital economy, any process that requires a human to click an approval button, route a task, or wait for banking hours is a system failure. That delay is pure economic leakage. To eliminate this latency, developers are building the Zero Human Company, a business structure where autonomous AI agents independently manage capital, deploy code, and execute operations. This is a structured hierarchy. As shown in this deployment matrix, specialized nodes like the CEO agent set global strategy, while the engineer agent deploys automated code, and the quant agent manages live treasury routing. Looking at the live system metrics, we can see these multi-agent workforces actively processing value. They execute millions of tasks and route capital across decentralized networks simultaneously, without ever requiring a human in the loop. The engineering barrier to deploying this at scale is cognitive continuity. Large language models are inherently stateless, making it extremely difficult to run a persistent, multi-day business process. To solve this, developers hard-code memory and strict economic logic directly into the environment. Verifiable machine execution is replacing human trust as the baseline requirement for digital infrastructure. For autonomous agents to operate capital efficiently, they require a frictionless settlement layer. Running a high-frequency machine economy on a single congested blockchain introduces unpredictable gas fees and execution delays that stall AI operations. The trinity of DLT unifies three consensus mechanisms. The XRP Ledger provides high-speed value transfer. Algorand ensures mathematical finality with zero fork risk. And Hedera logs sub-second cryptographic audit trails. By weaving these three diverse ledgers together, the system provides a zero-fee, high-throughput environment optimized specifically for autonomous machine-to-machine micropayments. Multi-chain abstraction is what allows these cognitive agents to transact at API speed. When network cost and friction are removed, the AI executes without ever waiting for human permission. With the settlement layer established, the infrastructure moves up to the cognitive layer. The paperclip AI orchestrator is the engine that organizes raw intelligence into rigid, hierarchical agent organizations. The orchestrator takes high-level strategic objectives and breaks them down into specific executable sprint tickets, assigning them to individual subagents based on their functional role. But this exposes the primary flaw of raw LLM APIs, the memento man problem. Standard models retain zero situational context between queries. When an agent executes a prompt, it powers up with capability, but once the API call concludes, it experiences total cognitive amnesia. If an AI is managing a corporate treasury or deploying a complex software audit, waking up blank at every step creates severe operational vulnerabilities. The agent forgets the overarching goal. Simply increasing the token context window of a model is a temporary patch. It massively bloats compute costs and slows down processing speeds for a problem that actually requires a strict structural engineering solution. Raw models cannot function as a persistent professional workforce. They require an external, localized memory framework to retain state across thousands of successive operational cycles. The system corrects this amnesia by initiating a recurring logic cycle called the heartbeat check-in system. Before executing any action, the heartbeat forces the subagent to read a mandatory organizational brief. The agent reviews its assigned corporate persona, its immediate objective, and the definition of success. This maps the agent's file-based memory architecture, structured around the para method. The agent queries 4 data silos: projects, areas, resources, and archives to orient itself. Once complete, it writes its deployment metrics back into the file system. This localized retrieval system means the AI only loads the exact files required for the task. It prevents token window dilution and keeps the machine's logic highly focused. Combining the heartbeat loop with structured filing turns isolated prompts into a continuous, stateful business workflow. Even with memory intact, autonomous execution faces a severe mathematical barrier known as the measurability gap. Automation is now incredibly cheap, but human verification remains biologically slow. This graph illustrates the risk of unverified multi-step operations. As defined by this equation, the probability of an end-to-end failure compounds exponentially with every successive step a single agent takes. A single AI model operates with a 95% accuracy rate per action. By the time it completes a standard 10-step financial process, compounding errors degrade its overall success rate to roughly 40%. To prevent these compounding failures, the orchestrator enforces Byzantine fault-tolerant consensus across multiple specialized models. The system introduces an independent quality assurance agent to audit the primary agents at intermediate checkpoints. This verification step resets the error probability, stopping the compounding decay and pushing system reliability near 100%. Before deploying code or moving capital, this agent council engages in a structured multi-model debate to validate the strategy and ensure compliance. Multi-agent consensus is the required defense mechanism. It mathematically rescues the architecture from the exponential degradation guaranteed by single-agent workflows. With the cognitive logic secured, the final vulnerability is the supply chain. If third-party agent scripts are granted access to the orchestrator, malicious tools could attempt to drain resources or compromise private keys. The system isolates operations within an architecture called the vault, deploying hardware-level enclave shields and decentralized biometric verification to prevent unauthorized key extraction. The strictest safeguard is economic. The platform enforces a Sybil-resistant entry mechanism requiring on-chain validation. To access root orchestrator privileges, a user must hold a minimum of 2% of the total DeFi token supply. The protocol runs a strict 3-step check. The node verifies the target asset balance in the connected wallet, cryptographically validates the holding, and only then unlocks the network interface. This creates a direct financial stake in the infrastructure. By locking access behind a massive token requirement, it aligns the autonomous machine workforce with the network's long-term economic integrity. The architecture is now fully compiled. High-throughput settlement rails support stateful memory frameworks, all governed by multi-agent consensus logic. Operating continuously without administrative bottlenecks, this enterprise automation layer eliminates over $100,000 in manual human overhead and legacy software subscriptions. This is a permanent departure from the token trading narratives of the early internet. The value has moved down to the invisible infrastructure layer, where protocols optimize for direct execution instead of user interface engagement. For systems architects, the mandate is clear. Design networks that convert intent directly into automated outcomes. Delaying an action for human attention is an architectural flaw. The zero-human company is an economic reality. The future of digital infrastructure belongs entirely to those who build systems that operate on logic rather than labor.